Hello, welcome to bond valuation. We're going to do a basic semi-annual bond valuation. In this particular problem, we're going to look at a bond that has 20 years remaining on its life. This means it could have been a 30-year, 25-year, 21-year bond, and some time has passed, but now there are 20 years left. And this bond is a semi-annual U.S. corporate bond. So that means in any 1 year period, there are two semi-annual periods. So that means two semi-annual periods means that's equivalent to year 1. The fourth one is equivalent to year 2, and so on. Year 19 would be 38 semi-annual periods, and year 20 would be 40 semi-annual periods. So this is our year timeline, and this is our semi-annual timeline. Now, how do we come up with the cash flows that you see on the timeline over there? Well, what we're going to do is we're going to come up with this 6.5% APR. That 6.5% APR, that's a contractual percentage rate. And what we're going to do is we're going to take 6.5% times the face value. In this case, the face value is not stated in the problem. It's $1,000. If the face value is not stated in a bond problem, then always assume that it's $1,000. So if we take 6.5% times 1,000, that means each year our investors are going to have an inflow of $65. Now, because this bond is paid semi-annual, that means the first 6-month period they'll get $32.50, and then at the end of the first year they're also going to get $32.50. So that first $32.50 is right there, and the second one is right there at the end of the first year. And that continues on for the full 20 years that we have. Now, as an investor, you're going to buy this bond today. And what we want to do is we want to find out what that value is today. That's the intrinsic value portion of what we're trying to do. Now, I've created this timeline where we've put all the cash flows on here, and you'll notice that that $32.50, because we get that every 6 months like clockwork for the full 20 years, that is the equivalent of an annuity stream. Whereas the $1,000 that we have here, that's a single cash flow. There's no other cash flows that we're receiving during that particular time period. So we want to find the intrinsic value right here at time 0. Now typically we could do some basic time value of money and discount each of these cash flows 1 period at a time, 2 periods at a time, and so on, and sum up all the cash flows, and we'd come up with the present value. But there is a much easier way for us to be able to do this. And what we're going to do is we're going to use our financial calculator. Now we're going to start out by entering in the key variables, and this will be the third row on your financial calculator. Now the number of periods here is semi-annual periods, so we have 20 years times 2, which is the 40 semi-annual periods. IY I'm going to come back to in a moment. The present value, that's right here. That's our guy right there. He wants to know what it's worth today. We do not know what that value is right now. Now the payment is the annuity payment. Whatever value you put here will always be an annuity. So this is the plus $32.50 as the investor. Now the future value, when the last $32.50 is paid, the question is there any other cash flows? Well, yeah, we've got this cash flow right here of $1,000 that we still haven't accounted for. So that occurs right at the moment we get the last $32.50, so we can put it in here as a future value. Now let's go back to the IY. Now up here in our problem it says that we had an 8% APR is what investors demand. Now I want to backtrack just a little bit. Now that 8% or the 6.5% that we talked about earlier, That 6.5% is a contractual element. That's in the bond indenture. The 8% is a market rate. So initially investors locked in that 6.5% into the contract because that was the going market rate. Now the market rate has gone up because of increased risk in some place. So now we want to get 8% a year, but everything that we're doing in this problem is based on semi-annual. So what we have to do is we have to say, well, if it's 8% for a whole year, if we divide it by 2, that tells us it's 4% just for that one particular time period. So when we put all these in, we can compute the present value. And that present value, when we compute it on our financial calculators, is going to come up with a negative sign, 851.55. Now the negative sign means as an investor, you're going to have to buy this bond for $851.55. That's the intrinsic value. When this bond was issued, it would have been issued at that face amount, or a value very close to that face amount of $1,000. So that bond has gone down in value. Since it's now less than the $1,000 face amount, we would say that this bond is a discount bond. If it were above, greater than is a premium bond. And if it were equal to, it would be at par or at the face amount. Now, one other thing to note. Let's compare the interest rates. I'm going to put them underneath here. We got 851.55 based on an 8% rate. If you put 6.5% in for IY, you would get a $1,000 value. In other words, 6.5% is associated with 1,000, 8% is associated here. Now let's look at the sign here. 8% is greater than 6.5%. So risk has gone up. Investors want a higher rate of return. The only way they'll get a higher rate of return, since all of these cash flows up here are fixed, is if they pay less for the bond. So the bond has gone down in value to $851.55.